So good afternoon everybody, myself Acharya Vishvendra. Let's discuss a worksheet on calorimetry. So here is the worksheet. So the first question is 100 gram of ice is at 0 degree centigrade. Then we need to find minimum mass of water at 80 degrees centigrade to completely melt ice. So here we calculate the amount of heat required to melt ice, which is given by m into L, so which is 100 into 80. And we suppose that the mass is m0, so the heat supplied by the water will be m0 1 into 80. As we have calculated the minimum mass, so we assume that the final temperature is 0, so that there is no extra heat left, so that will give the minimum value. So from here the calculations gives m0 is equal to 100 gram. Then is the next question, if mass of water is m0 by 3. So obviously if mass is less than the minimum mass, so complete ice will not melt. That means final temperature will be 0 degree. Next is equilibrium composition if mass of water is m0 by 3. So here we calculate that final temperature is 0, so complete ice has not melt. So we calculate the amount of ice melt, which is given by this expression. Suppose m dash ice melt, so heat required will be m dash into 80, and heat supplied by water will be m0 by 3 into 1 into 80. So from calculations m0 comes out to be 100 by 3. So that means finally 100 by 3 ice will melt, so that will give water. So the total mass of water is m0 by 3, which is formed by melting of ice, and m0 by 3, which is due to the water present. So the total will be 2 by 3 m0, which is 200 by 3 gram, and mass of ice left will be m0 minus m0 by 3. After calculations it comes out to be 200 by 3 gram. Next is equilibrium temperature if mass of water is twice of m0. So since mass is greater than m0, that means final temperature will be greater than T. So complete ice will melt. So we calculate the heat required for the temperature to raise through. Let's say assume that the final temperature is T. So comparing for ice, this energy will be needed for melting it, plus ms delta T, that will be heat required to increase temperature by T. So total heat absorbed by ice will be this. Now we calculate the heat supplied by water, which will be 200 into 1 into 80 minus T. And after all the calculations, T comes out to be 80 by 3, which is 26.6 degrees centigrade. Next is we need to find equilibrium composition in this case. So obviously ice will melt completely and temperature is 26.6. So complete transfer will be the water itself. And here ice will be 0 gram. Next is equilibrium composition if mass is